welcome to the deep dive. So, you're likely here because, well, Bitcoin's caught your eye, right?
Yeah.
But maybe it all feels a bit overwhelming, like trying to read some kind of secret code.
Yeah, there's definitely a lot of jargon flying around.
Exactly. So today, our mission really is to give you the decoder ring. We're focusing specifically on how Bitcoin transactions actually get authenticated. We've been digging into this really clear article that breaks it down, and the plan is to pull out the essentials so you can quickly get a handle on how it works and why it actually matters.
Right, and what's kind of amazing right from the start is how Bitcoin handles security and trust without needing the usual suspects like banks.
No middleman.
No middleman. The whole authentication thing is just built right into the technology itself. And the absolute core of that is cryptography.
Okay, cryptography. Now that word, it sounds pretty heavy, maybe a little intimidating.
It can, yeah.
But in this context, it's really about making sure interactions are secure, especially online where you don't know everyone. The article we looked at really hammered home the idea of public and private key pairs.
That's the foundation. So think of your private key, like your super secret digital signature. It's yours, you keep it totally safe, and you use it to basically sign off on any transaction you want to make.
Like saying, yep, this is me sending this.
Exactly. It's your authorization. Now, the public key, that's different. You can share that one freely. It lets anyone else on the network check that, yes, a transaction was definitely signed by the correct private key.
Okay, so the private key makes the signature. The public key lets others check it's legit. It's kind of like having a special mailbox.
Yeah.
Only your private key can put mail transaction in it. But the public key is like a little window so everyone can see the mail was put there by the right key. Does that track?
That's actually a really good way to put it, yeah.
Yeah.
And that digital signature is just vital. It proves the transaction came from the actual owner of the Bitcoin.
Right.
And crucially, that it hasn't been, fiddled with en route. This whole crypto setup gives you integrity and a certain level of anonymity, too.
Okay, so a transaction gets signed, stamped with approval, using that private key. Yeah. Then what? Where does it go? That's where the blockchain comes in, right? The article called it a distributed public ledger.
Precisely. Imagine like a giant digital notebook, a really, really big one, and everyone involved in Bitcoin has their own identical copy.
Everyone. Wow.
Yeah, well, everyone running the software. And this notebook, it keeps a perfect record of every single Bitcoin transaction that's ever happened. Total transparency, basically.
Okay.
So when new transactions are made and signed, they get sort of gathered together into batches, into groups. We call those blocks.
Blocks, right. And these blocks then get attached to the previous block, making a chain, hence blockchain.
You got it, blockchain. And the article mentioned miners, didn't it? They're pretty important here.
Yeah, what's their deal? What do they do?
Well, it's interesting. These miners, they're essentially competing against each other. They race to check and validate these new blocks full of transactions.
Competing how?
By solving a really complex mathematical puzzle. It takes a ton of computing power. And the first one to solve it gets to add the new block to the blockchain.
Okay, so it's like a race that requires serious computational muscle.
Exactly. And that computational effort, that difficulty, it serves a purpose. It makes it incredibly hard and expensive for anyone to go back and try to change past transactions.
Ah, okay, because they'd have to redo all that puzzle-solving work for that block and all the ones that came after it.
Precisely. It quickly becomes practically impossible. So once a block is solved and added, the article mentioned it becomes immutable, set in stone.
Immutable, meaning non-changeable.
Correct. It's a permanent record.
Right.
And because this whole ledger, this blockchain, isn't sitting on one company's server somewhere.
Right. It's distributed.
It's distributed across thousands, maybe millions of computers worldwide. That's the decentralized part. No single person or group controls it or can mess with the history.
Okay, that makes sense. So cryptography locks down the individual transaction. The blockchain makes the history transparent and permanent. But hang on. If you've got all these different computers, these miners, all over the place, how do they all agree?
Good question.
How do they agree on which transactions are valid, which block is the right one to add next? Seems like there could be arguments, right? The article called it consensus mechanisms.
Yeah, that's the key, isn't it? In a system with no boss, no central bank telling everyone what's what, how do you get everyone on the same page? That's what a consensus mechanism does.
Okay.
And for Bitcoin, the main one, the original one, is called proof of work, POW. And it's directly tied to that intense computational work the miners are doing that we just talked about.
The puzzle-solving race.
Exactly. That huge effort they expend isn't just about validating transactions, it is the consensus mechanism. By successfully doing the work, a miner proves they've validated the block correctly, and the rest of the network basically accepts that proof. It ensures the vast majority agree on the state of the ledger.
So the sheer difficulty of doing that work,
Yeah.
it validates the block and it stops people from cheating, like trying to spend the same Bitcoin twice. Double spending, is that the term?
That's the one. Proof of work makes double spending incredibly difficult and costly to attempt. So let's walk through a transaction step by step. Say you want to send some Bitcoin to a friend.
Okay.
You use your private key, create that unique digital signature. Then that signed transaction gets broadcast, like shouting it out, to the whole Bitcoin network.
Just out into the ether, sort of?
Pretty much, yeah. To all the other computers or nodes running the Bitcoin software. And as the article laid out, lots of these nodes immediately start checking it.
Checking what?
Things like, is the digital signature valid? Does the sender actually have enough Bitcoin to send? Basic checks.
Right, makes sense. Once enough nodes agree, yep, this looks okay, the transaction is considered preliminarily valid. It then gets bundled with other valid transactions into a potential new block.
And that's when the miners jump in for the proof of work race.
That's it. Miners grab that block, start crunching the numbers, trying to solve that puzzle. When one miner finds the solution, they broadcast it, add the block to the chain, and then your transaction is officially confirmed. Usually takes a few more blocks added on top for extra security, but that's the gist.
Wow. Okay. It sounds involved, but also really secure step by step. The article kept coming back to decentralization being key. Why is that so fundamental for, making sure these transactions are authentic?
Well, if you think about the alternative, right? Centralized systems, like your bank. There's one authority, one point of control. They verify everything.
Yeah.
Bitcoin flips that. It's peer-to-peer.
Yeah.
The job of checking and recording transactions is spread out across this huge network. So there's no single point of failure. No one entity you have to trust implicitly. So you don't need to trust any one participant because you can trust the system, the network as a whole.
Exactly. The security comes from the distribution, the transparency of that public ledger everyone can see, and the consensus rules everyone follows. Trust is built into the protocol, not reliant on an institution.
It's the transparency and the collective agreement that makes it work.
Precisely. No single player can just change the rules or declare a fake transaction valid. The network, through consensus, authenticates everything.
Now, the article did briefly mention challenges. Network congestion.
Yeah.
What's that about? Does it affect this authentication process?
It's more about speed, really. Think of each block in the blockchain as having limited space, like pages in that notebook.
Okay.
If loads and loads of people are trying to make transactions all at once, the network can get busy. There might be a queue for transactions waiting to get into a block.
So it might just take longer for your transaction to get confirmed if the network's really clogged up?
Yeah, exactly. It doesn't really undermine the security or the authentication, but it can lead to delays and sometimes higher transaction fees if you want to jump the queue. It's basically a scaling challenge.
Right, gotcha. Okay, so let's try and wrap this up for anyone just trying to get their head around Bitcoin. The authentication, making sure transactions are real and legit, it boils down to a few key things working together. First, you've got cryptography, those private and public keys making digital signatures.
Yep, securing the individual transaction.
Second, there's the blockchain technology itself, that shared public unchangeable ledger.
The transparent record keeper.
And third, you need that consensus mechanism like proof of work for Bitcoin to make sure everyone on this spread out decentralized network agrees on what's valid.
That's the agreement engine. And it's really that powerful mix, the crypto, the blockchain, the consensus, all running on a decentralized network that ensures Bitcoin transactions are secure and have integrity. You don't need to trust a central party because you can trust the code and the network.
So for you listening, now that you've got a bit more of a handle on how Bitcoin actually authenticates transactions in this, well, unique way, what else are you curious about? Maybe it's, I don't know, how mining really works. Or perhaps the environmental discussions around proof of work.
Or even other cryptocurrencies that use different methods.
Yeah, lots to explore. We definitely encourage you to keep digging. Thanks for joining us for this deep dive.